What's up everybody, Aditya Mahajan here and welcome back to yet another LeetCode video. Now the problem that we'll be looking at today is 941, also called as valid mountain array. Now this is part of the arrays playlist, so if you haven't checked it out, do check the link in the description. Now the problem statement states that we are given an array of integers and we need to return true only if it is a valid mountain array. Now they have given some things to define a valid mountain array, that is the array's length should be greater than or equal to 3, and for every element there should be an index I, so that all the elements before I should be increasing, and all the elements after that should be in the strictly decreasing. Now strictly increasing and strictly decreasing are important here, because when we say even increasing, then it could mean that we can have two elements same, so this is not a valid mountain array. For example, we have two arrays, 2 and 1. So in this, it is actually just strictly decreasing and we do not have any peak in there. So this is not a valid mountain array. Similarly, we have strictly increasing in second example. The only valid mountain array is the example number 3, which is 0 to 3. Here it is increasing and then it is decreasing from 3 to 1. Okay, so now to solve this problem, we basically have two approaches. Let us look at the first approach. Now, for the first approach, what we can do is, if we take a look at the problem statement, they are mentioning strictly increasing and strictly decreasing very prominently. Now, what this would mean is that there would be one point before which, if it is a valid mountain array, before which all the elements should be decreasing if we go in reverse order, and after that, all the elements would be decreasing. Okay, so there would not be two elements similar, right? So there would be only one peak point. So in this approach, what we'll be doing is we'll be finding the max point in that array. So if there exists some peak in that array, then it would be at the max element. All right. So once we have the max element, what we'll do is we will start from the 0th index and check till the max if it is strictly increasing, and same after the index till the end if it is strictly decreasing. Now there is one more case that we need to take into account, is that when it is just strictly decreasing or just strictly increasing. Okay, what I am saying by that is I'm telling about the example number 1 or example number 2. So let us take a look at how we can take into consideration for that. So the solution goes something like this. Now there we had an initial condition, that is array length should be greater than or equal to 3. If that is not the case, then we are just returning false because it is not a valid mountain array. After that, what we are doing is, we are from the vector given, we are finding the maximum element and the index where that maximum element is present. So we are having two values, max and index, which we are iterating through the complete vector to find where the max is. Whenever we find a max, we are just updating index and max value. Now what we need to do is, we have found the peak of that particular mountain, if the mountain exists, and if it exists, we need to check that if it is not strictly increasing or decreasing. Now if it is strictly increasing or decreasing, what would happen is the peak would be at the 0th index, that is it would be strictly decreasing, or the peak would be at last index, that would be strictly increasing. So if both are the cases, that is index is 0 for the max element or index is last element, in that case we just return false, because it is not a mountain, it is just strictly increasing curve or strictly decreasing curve. That is also we do not want. Now we need to check that. We need to check if there is a possibility of just increasing but not strictly increasing. That is two elements would have same elements. So to check that, what we'll be doing is, till the index value or the max value, we are checking all the elements before that are increasing. So that is what we are doing. Till the index from I equal to 1, we are checking if a of I is greater than a of I minus 1. So the next element is greater than the current element, and here it is strictly greater than, not greater than or equal to. So if that is the case, we are just continuing further. If that is not the case, that is we have found an element which is smaller or equal to, in that case we are just returning false, because then it would not be a valid mountain array, because this is not the max element or the peak that we had found. Once we reach till the index, that means that it is strictly increasing till the index. Now we need to check if it is strictly decreasing. So we will be iterating from the index till the last element, that is n minus 1, and we'll be checking if a of I is greater than a of I plus 1, that is first element is greater than the next coming element. And same, if it is if it satisfies, we are just continuing. If it is not, it is not a valid mountain array and we are returning false. Now once all these checks are done, this means that we are at the valid mountain array. Now this is a solution. This is the first approach. Now, if we take a look at the second approach, what other thing we can do is we can do it with the help of two-pointer approach. Now, in this approach, we found the max and then we are checking from increasing or decreasing. What we can do is we can do the operation from both ends at the simultaneously. So it would be a sort of two-pointer approach where what we'll be doing is we will starting from the start and also from the end, and we will keep on incrementing the start and decrementing the end till we have strictly increasing and strictly decreasing. Now, once we find a discrepancy, that is, we find a peak, that is, it changes its inclinity, that is, from increasing to decreasing, we will stop there and we will compare both the indices, that is from the start and from the end. If they are equal and they are inside the array, not the first and the last element, then it would mean that we are having a valid mountain. So let us look at the solution what we have. So this is the approach for the second two-pointer method. So what we are doing is we are taking firstly the size of the element, size of the vector, not the element, and then we are initializing two pointers, that is I equal to 0 and j equal to n minus 1, that is start and the end. Now what we are doing is we are starting from the start, that is from 0th element till we have a decrease, that is the inclinity changes, that is it does not remain strictly increasing. So our two conditions would be I plus 1 is less than n, and a of I, that is the element of ith index, is less than element corresponding to that. Now till we do that, we are just incrementing that, and same goes for decreasing. What we are doing is once that complete thing is done, we will have a point where I would be the sort of peak. If it is a peak from decreasing as well, we have a valid mountain array. So that is what we are doing. So we will be doing decrementing j till it is greater than 0, that is it does not go out of bound, and a of j minus 1 is greater than a of j, that is its next element, or if we are going in reverse, the previous element is greater. Okay, so till that we are just decrementing j minus minus. Now once we are out of these two both while loops, what we'll be checking is both are not the endpoints. So we saw that if both are endpoints, it would be a strictly increasing or strictly decreasing. That is the reason why we are checking if j and if I and j are not the endpoints and they are equal. If they are equal, in that case we are just returning true because it is a valid mountain array. Otherwise we are returning false, saying that it is not a valid mountain array. So yeah, that's the second approach with the two pointer. Not exactly two pointer, but yeah, the second way of doing this solution, the solution for this problem. So if you did not understand, comment below. I'll try to respond as fast as possible. If you need more such LeetCode content, subscribe to the channel, and that's all. I'll see you in the next one.